Good morning, gentlemen. Today we're going to talk a little bit about area and volume of similar solids. I know that you've already done area of similar plane figures, flat shapes, two-dimensional shapes, and so now we're doing pretty much the same thing, but we're going to add a little extra to that now that we're talking about three-dimensional solids. I do think it's probably a good idea to just take a look at this particular problem and see if you can figure out what that relationship is on your own. So it's a good idea at this point to just pause the video, read through the problem, and try to figure out this one on your own. I think you're not really going to have much difficulty. I'm going to go ahead and start to work through it, but it's a great idea to pause it. So a baker's making a 3-layer wedding cake. Each layer has a square base, and the dimension is half the corresponding dimension of the bottom layer. Middle layer, and then each dimension of the top layer is half the corresponding dimension of the middle layer. So if this one is 4 inches, that means this one must be 2 inches, right? And if this dimension right here is 8 inches, that means this one must be 4 inches. And then if this dimension is 8, this dimension is 4 as well. And then we'll also do the top layer. So if this dimension is 2 in the middle layer, that means that this height of that top layer must be 1 inch. And then for the square base, that must be 2. And then 2 for this dimension as well. Okay, so we want to compare. Right? We want to calculate the volume, and what we want to make a conjecture about the relationship between the volumes of the layers. And that's what we're going to start off with. So let's see about calculating the volume of the bottom layer. Right? And remember that we have a rectangular prism. And if we have a rectangular prism, then remember that we can just do length times width times height. So the volume of the bottom layer is going to be 8 times 8 times 4, which is going to be 256 cubic inches. Okay, now let's do the volume of the middle layer. And then we halved each dimension. So now we're going to do 4 times 4 times 2. And we're going to get 32 cubic inches. And we're going to do the volume of the top layer. And we're going to get multiply 2 times 1, obviously, and get 4 cubic inches. So we're trying to see if there's a relationship between these. And we want to make a relationship between the volumes of the layers. So let's see if we can figure out what that may be. Let's compare the volume of the middle layer to the volume of the top. A volume of the bottom layer. And so let's make a ratio to compare those. 32 over 256, and you should reduce that fraction, and you're going to get 1/8, 1 over 8. And let's do the volume of the top layer to the volume of the middle layer, because we halved each dimension. So then we're going to have 4 over 32, which again gives us 1/8, right? So let's think about those things a little bit. And can you find a relationship? So that relationship was, the ratio was definitely the same, obviously, when you're comparing, because you halved each dimension, right? But let's think about the scale factor. What was the scale factor? The scale factor was 1/2. You did half of the bottom layer to get the middle and half of the middle to get the top. So the ratio of the volumes was 1/8. And how does that compare? I know sometimes it's hard to see that when the 1 doesn't look any different, but the 2 does. So let's talk about that just a little bit on the next page. For similar solids, the similar solids have the same shape and corresponding dimensions are proportional. Remember, just like similar polygons have corresponding angles that are congruent, corresponding sides that are proportional. We're going to determine if the 2 rectangular prisms are similar, and if so, we're going to give the scale factor, right? So we're going to compare length of the small to length of the large, and width of the small to width of the large, and height of the small to height of the large. And if we reduce each one of those, we get the same scale factor, right? And scale factor is 1/2, and we say yes, they are similar. Now let's do the same thing in problem B. We're going to compare length of the small, length of the small would be 3, to length of the large rectangular prism, and then width of the small to width of the large, and height of the small to height of the large. And clearly we do not get the same ratio, right? The 1/2 is not the same as 2/3, so these are not similar. Just make sure you can determine if two solids are similar. Okay, so let's talk about that relationship a little bit. And so we're going to just explore just a little bit more and experiment just a little bit more so we can see that relationship. Let's identify the scale factor comparing these. So we've got 2 to 4, 1 to 2, 3 to 6. They all reduce to 1/2, right? They all reduce to 1/2. Now let's compare the ratio of the areas. When we compare the ratios of the areas, the surface area of the small is 22 square meters, and the surface area of the large is 88 square meters. And when we reduce that, we get 1/4. So how to think about how that compares: the 2 could be doubled to get the 4. Also, the 2 could be squared to get to 4. Remember that area is units squared. And the 1, if you double the 1, you don't get 1, but if you square 1, you also do get 1. Okay, so think about that as squaring the scale factor, right? That maybe is what's going on there. Okay, and let's compare the ratio of the volumes. If we take the volume of the small rectangular prism and compare the 6 to the volume of the large, 48, and if we reduce that by 6, then we get 1/8. And again, if we double the 4, we would get the 8. But if we're doubling the 1, we don't get that. So how does that compare to the scale factor? So how do we get from 2 to 8? We could quadruple it, multiply the 2 by 4, but multiplying by 1 by 4 wouldn't give us the 1. And think about volume is measured in cubic units, right? So what do you think with the scale factor? Probably if we take that scale factor and cube the scale factor, maybe we would get the volume, right? Okay, so let's talk about that a little bit. So to find the ratio of the areas, if the scale factor is A over B, then the ratio of the areas is going to be A squared over B squared. And the ratio of the volumes, because volume is measured in cubic units, is going to be A cubed over B cubed. And if you didn't recall from the last section about spheres about how to raise something to the third power, you can take any number, like for example 5, and on your TI-30X2 calculator you can use the caret symbol, which looks like a little roof, right? And it should be right below the pi. Use the caret symbol to raise something to the third power, and that'll give you 125, 5 to the third. You can check that and just multiply 5 times 5 times 5 if you wish. But then you can just raise anything to whatever power you need to raise it to by using the caret symbol, okay? And you should remember that from our discussion about spheres a little bit. All right, so we're going to find the scale factor of 2 cubes with a given volume of 729 centimeters cubed and 1331 centimeters cubed. So we're going to compare 729 to 1331. Sometimes one of the first things that I'll do is I'll just try to reduce that fraction and see if they are divisible by the same amount. And in this case, they're not. So when I check that on my calculator and try to reduce that fraction, they're not. So if this is equivalent to the scale factor cubed, then what I need to do to find the scale factor is I'm going to have to take the cube root of 729, and the cube root of 1331. So in case you forgot how to take the cube root, remember that you have to tell your calculator that you want to take the third root or the cube root. So you would press 3 first, and then you would press second, and then you would press that caret key, because above that caret key is a little X root, which means you could take any root. It doesn't have to be the cube root. You could take the fourth root, but you'd have to tell it that you want to take the fourth root first by typing 4 instead of 3. So 3 second and cube root, or 3 second caret of 729 gives you 9. So then you get 9 over, and the cube root of 1331 is 11. So the scale factor is equivalent to 9 over 11, and you're done. All right, so let's put it into practice a little bit more like the types of problems we want to be able to work on a regular basis. So we have the lateral areas of two similar paint cans are 144 pi centimeters squared and 64 pi centimeters squared. And we have the volume of the small can is 28 pi centimeters cubed. We want to find the volume of the large can. So in order to do that, we really need to be able to find the volume of the large can. We need to be able to say that a cubed over b cubed is equal to 128 pi over whatever that volume. So let's say that x equals this volume of the large can. That's what we want to be able to do. But in order to do that, we need to know what is the scale factor. So if we don't know the scale factor, we've got to find that first. So how can we do that? So we can use the lateral area to make a comparison of the areas of the volumes, right? Notice that if the volumes are 144 pi and 64 pi, that means that this must be the smaller paint can and this must be the larger paint can. Just be careful and mindful of whether things might be given in an out of order type of way. So when I make this comparison, I'm going to say 64 pi over 144 pi. And of course you can cancel the pi's and just reduce that a little bit. And then reduce your fraction, 64 over 144. And when you reduce that fraction, you're going to get 4 over 9, right? Okay, but this is just a comparison of the areas, the lateral areas. So this must be area squared, a squared over b squared. That's that comparison, which means that if we take that square root of the left side and we take the square root of the right side, then that means the scale factor must be 2/3. That's your scale factor. And that is what we're going to use to figure out what the volume of the larger paint can is. So now we're going to take the 2/3 and we're going to say 2 cubed over 3 cubed is equivalent to 128 pi over x. And we'll go ahead and cross multiply. That might be a little bit easier for some of us. So let's multiply let's do the 2 cubed. 2 cubed, remember, means 2 times 2 times 2, and that's 8x equals 3 cubed is 27. I'll just write 27 times 128 first, 128 pi. And then if you want, you can go ahead and multiply the 27 times 128. I have a tendency, again, to try to simplify things as much as possible first. I'm going to divide 8 into 128, right? And when I do that, I'm going to get 16. And then I'll multiply 16 times 27. So x is equal to, and 16 times 27 is 432. The pi is still there. That didn't cancel. So the volume of the larger paint can is 432 pi cubic centimeters. And I'm going to leave it as exact because it was given as exact. So I'm not going to approximate. Just remember to always follow your directions. And then in general, you can use that. Always remember that you want to find, if you're given the lateral area or you're given the volume, you definitely want to find the scale factor before you proceed to find either the lateral area if that's missing, or the ratio of the lateral area or the ratio of the volumes, whatever it is you're looking for. And that's it. That's the end of it. Have a great day.